Hello, welcome you all. So, last class we have discussed about example 8.3, 8.4, and 8.5 in chapter 8 motion, class 9. So, today's class we are going to see about two example sums, example 8.6 and example 8.7. Okay, so let's move on to the question. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and distance covered by the car in that time. Okay. So please look into that. So the acceleration they are asking, and so we need to find the distance covered by the car. So we are moving on to the formula section. So already you know that the first equation of motion, second equation of motion, and third equation of motion. So these are the formulas we are discussing now for example 8.5, 8.6, and 8.7. So last class in example 8.5, so we have discussed about third equation of motion with respect to example we have discussed. So now, so please look into it. You know the formula for acceleration. Acceleration is equal to v minus u by t. Okay. So what are the data has been given? So a car accelerates. So one A is accelerating. So A to B. So from 18 km per hour to 36 km per hour. So the initial velocity u is equal to 18 km per hour and v is equal to 36 km per hour and v is equal to 5 seconds. You know, a kilometer per hour to be converted as meter per second. So that is would be a minor conversion, like into 5 to 18 we need to multiply. So we'll get the value of the initial velocity as u equal to 5 meter per second and same v is equal to 10 meter per second. Okay, so if you done with the 5 by 18, so kilometer per hour to meter per second conversion, so you need to multiply with the value of 5 by 18. And so you need to apply with the formula. So A is equal to V minus U by T. So I have to substitute the values. So V is equal to 10 meter per second, 10 minus 5 divided by 5. So T is given in the question. So 5 seconds. Okay. So 5 by 5. So 10 minus 5 is 5. 5 by 5 is 1. So A is equal to 1 meter per second square. So coming to the second question, they are asking distance tab covered. So what is the distance covered in the sense? Yes, S is the distance. So is that S is given S equal to ut plus 1 by 2 at square. Okay. So you know the value of u, you know the value of t, you know the value of a, and you know the value of t. Okay. So what is the value of u? U is 5. So t is 5 and plus 1 by 2, 1, 5 square. So if you 5 into 5, 25 plus 1 by 2 into 1 into 25. 5 square is 25. So if you multiply with the values, you will get 25 plus 25 by 2. So you need to take LCM or cross multiply. So 25 into 2 will be 50 plus 25 by 2. So you'll get the 75 by 2. So the answer would be 37.5 meter because we need to find the distance. So yes, so S equal to 37.5 meter. So coming to the example 8.7, the brakes applied to a car produce an acceleration of 6 meter per second square in opposite direction. So please read the question in opposite direction is given to the motion. The car takes 2 seconds to stop after the application of brakes. So after the brake has been applied, it takes 2 seconds to stop the car because so we are moving on to 90 km per hour means so if we apply brake means so the car slowly stops down. So it will take time, no? So that time. So calculate the distance it travels during this time. So how many distance they are asking? Okay. So if opposite directions means so it's minus. So acceleration is given. So acceleration of 6 meter per second. So A is equal to minus 6 meter per second square. T is equal to 2 seconds because after applying the brake only, the car will stop. So V is equal to 0 millimeter per second. V is velocity. What velocity? It's final velocity. Okay. So you know the first equation of motion. V is equal to U plus AT. So U, what is U? You need to find the value of U only. So that is called as initial velocity. So they have not given the question, they have not given any initial velocity. So they have only the car has stopped means so a final velocity would be 0. So at what speed it's going, the car, what speed it's going, so they are not given. So we need to find the value of initial velocity. So V is equal to 0, we have to put, and you have to keep it as, and A is minus 6, and T is 2. So if you multiply 6 into 2, so you'll get minus 12 because minus is there. So minus 12. So U is equal to minus 12. So if you get this answer, U is equal to 12 is coming. But U is equal to 12. So sorry, U is equal to 12 you are getting. So and then you have to substitute with the distance because they are asking only the distance covered. So the formula would be S equal to ut plus 1 by 2 at square. So you have find the value of u, you know the value of p, you know the value of a also, so you know the value of t also. Okay, so once you substitute with these values, so you can able to get the answers. So let's say u is equal to 12, t is equal to 2, 12 into 2, 24 we are getting. So 1 by 2 minus 6, 2 square. So 2 and 6 would get cancelled. So you get minus 3. So here 2 square will be 4. So minus 3 into 4, 12. So S equal to 12 meter. Okay. So these are all about example 8.7. So further classes, we will discuss about exercise sums of 8. Chapter 8 motion.